now we are working on double angle formulas. So this one happens, it's not okay to have a number in with the angle. It's not okay to have a 2 there. It's not okay to divide by 2. So if we have a number in with the angle, we're using formulas to get rid of it. So you'll notice here I have a 2 with the u, but when I use the formula, it's just a u. Same thing down here. I have a 2 with the u, but when I use the formula, it's just a u. Cosine has 3 different ones. Sometimes one works better than the other. It's just a matter of getting used to that. And then tangent has this amazing fraction that's annoying to work with. So this is double angle formulas, and we might as well just get started using them. I think it's another blank page. It's not going anywhere. Okay. So here I want to solve for u. I want to figure out what angle u is. But before I can do that, again, I told you it's not okay to have a number with the u. So we're going to use the double angle formula to get rid of that. So I still have 2 cosine u. But now I'm going to use my double angle formula to get rid of that. And the double angle formula for sine of 2u is 2 sine u cosine u. And it equals 0. And now for the fun part. They both have a 2 cosine u in them, so I can factor that out. When I factor out 2 cosine u, I still have a 1 here, and then I have a sine u. Okay, now that I have 2 things being multiplied that equal 0, I can set them equal to 0. Divide by 2. 0 divided by 2 is just 0. Subtract 1. And now I'm trying to figure out when does this happen. When does cosine of u, what angle does cosine equal 0? And it's going to happen here and here. So u equals pi over 2 and 3 pi over 2. And then sine is the y value, and y equals negative 1 when you're down here, which we already have. So here's my answers for that. Okay, we're not doing that. Okay, so we're supposed to find sine 2u, cosine 2u, tangent 2x when the cosine of x equals 5 over 13 and x is in the 4th quadrant. So let's get a little drawing going on here. We have to first put x in the 4th quadrant. Okay, so there's x. I know that cosine of x is adjacent over hypotenuse. And so if I do the Pythagorean theorem, that means this is negative 12. And it's negative because the y value is negative in that quadrant. Now I want to find the sine of 2x. Now I want to point out that 2x is not the same as x. You're not going to find the sine of x and then double it. That's not what this isn't a 2 sine x. This is a sine of 2x. So we can't just take these and double it. We have to use the formula. And the formula says that's going to be 2 sine x cosine x. So it's going to be 2 times the sine of x is opposite over hypotenuse. The cosine of x is adjacent over hypotenuse. And so you get, see, that's 2 over 1, negative 120 over 169. That would be the sine of 2x. Okay, then we have the cosine of 2x. Now there's all kinds of, there's 3 formulas for the cosine of 2x. I usually try to choose one that doesn't have too many trig functions in it, because the first one has sine and cosine. So I'm going to go with 2 cosine squared. So that means I'm going to take cosine adjacent over hypotenuse, and I have to square it. So then we get 2 times 25 over 169 minus 1. And so then this is 2 over 1, so I get 50 over 169 minus 169 over 169, get a common denominator, and we get a negative 119 over 169. And then we have to find the tangent of 2x. Now, one cheating method, it's not really cheating, but it's kind of brilliant, is to take the sine over the cosine, because that's tangent. And so that works out really nice, because 120 over 169 divided by negative 119 over 169, these guys cancel out, so you just get 120 over 119. And so that's tangent. Okay? However, there's going to be times where you don't have that and you have to use the formula for tangent. So we're going to look at the formula for tangent and use it. So the tangent of 2x equals 2 times the tangent of x over 1 minus tangent squared x. You need to know how to work your fractions here. The tangent of x is opposite over hypotenuse. No, it isn't. No, it isn't. Tangent of x, let's try that again, is opposite over adjacent. And it's still opposite over adjacent. So this is 2 over 1, so I get negative 24 over 5 over 1 minus, and then when you square that, you get 144 over 25. So you get negative 24 over 5 over, this would be 25 over 25, and you subtract 144, I don't know that, minus 1, you guys help me out, 19. Oh, well, you're not helpful. Over 25. Multiply by the reciprocal, 25 over negative 119. So it's gone now, it's reciprocal. 5 goes into 25 5 times. 5 times negative 24 is negative 120 over negative 119. Negatives cancel, and there's tangent of 2x. Which we already got, but that's a long way. Okay. Oh, we're not going to do that for today. Half angle, the fun ones. Okay, half angle, they have square roots in them. That's one of the fun things. And then the other one that we've talked about a lot is you need to figure out what u is and then put that number in right there. You're not going to put this whole thing in right there. You're just figuring out what this number is and putting it right there. So for example, if we're trying to find the sine of 105 degrees, we first start by rewriting it as something over 2. So what do you divide by 2 to get 105 degrees? 210. Okay, so we're in sine. That means if I go up to the identity, I'm going to go right here, and that is going to be 210. So I have 1 minus the cosine of 210 degrees all over 2. Now, as far as the plus or minus goes, where is 105? Which quadrant? Second quadrant. Is sine positive or negative? It's positive, right? Sine is the y value. It's positive there, so this will be a plus. The only reason for this plus or minus is because you have to determine whether it's positive or negative. Okay, then we just now continue on with our formula. So, this will be fun. 1 minus the cosine of 210 degrees. That's right here. That's like a 30, right? So cosine is the adjacent, or sorry, the x value, so that would be a negative root 3 over 2, all over 2. So this will be a plus. And then I get the square root of 1 plus root 3 over 2, which will be 2 over 2. That's all over 2. So then we have 2 plus the square root of 3 over 2 over 2. And because I have a fraction going on here, I'm going to make this a fraction also, and I will multiply by the reciprocal. So now I have 2 plus root 3, and on the bottom I'll have a 4, which is nice because I can square root the 4, right? Square root of 4 is 2. And so on top I'll be left with the square root of 2 plus the square root of 3. And so inside the square root we'll have a square root. We're just going to let it be and keep that.
Can you just get rid of kind of those square roots cancel each other out?
If one was a squared, they're both square roots. So no, it's like a double square root. Okay, then we have things like solving this equation. So now we're going to solve for the x, but I forgot what all I talked about. Okay, so you can't have a number in with your x. So that means that we have to use a formula to get rid of it. We're going to use a half angle for cosine. And so I'm going to copy down what I have on the left. Now notice cosine is squared, so I'm going to take and I'm going to square this whole thing. And then I'm going to plug in the formula. Formula is plus or minus the square root of 1 plus cosine of x all over 2. And now as I start to solve this, I see I have a plus or minus. Now that's going to be taken care of by the squared, because either one, if I square it, is going to cancel out. And then also I square the square root, and those cancel each other out. So now I have 2 minus sine squared x equals 2 times 1 plus cosine x over 2. And then this is kind of nice because these 2's are going to cancel. I have a 2 on top and a 2 on bottom. So now we have 2 minus sine squared x equals 1 plus the cosine of x. And a lot of people at this point kind of freak out because we have sine squared and we have a cosine and they're not the same thing. So what you need to do is use trig identities, Pythagorean theorem, Pythagorean identities to change sine squared into 1 minus cosine squared. So those don't go away. And then I still have 1 plus cosine on this side. And I need to distribute my minus sign. So it'll be 2 minus 1 will just be 1. Distribute the minus sign there and I'll get a plus cosine squared equals 1 plus cosine of x. Okay, get everything to one side. So I'll subtract 1 from both sides. They cancel out. And I'll move cosine of x over. So we have cosine squared minus the cosine of x equals 0. This is not going to be double bubble because I only have the two things. I'm going to factor out a cosine. And I'm left with the cosine of x minus 1 equals 0. So now that I have two things being multiplied, I can set each one equal to 0. This one's already solved, but this one I can move the x over, or the 1 over. So on my unit circle, cosine of x equals 0. Cosine is the x value, so it equals 0 at pi over 2 and 3 pi over 2. So x equals pi over 2 and 3 pi over 2. And the x value equals 1 for the next one at 0, so then that 0 will also be an answer. And that is that.